Hey guys, it's Coach Tapman, and today we are going to be talking about pulleys as a simple machine. So what is a pulley? A pulley is a wheel on an axle or shaft that is designed to support movement and change of direction of a taut cable or belt, or transfer of power between the shaft and cable or belt. So what does that mean? Well, let's get a visual. Really, this pulley, this whole assembly here, is intended to change the direction of a force for the benefit of the user. And so in this scenario, if you want to lift a block, you can attach a rope to the block and run it over a pulley, and then instead of needing to be over top of the block, you can also be on the ground. There are also mechanical advantages that are provided by pulleys that we can see in this next slide. And so because we know that the sum of the forces about any point is always equal, so if you consider right here, you have this weight hanging, and you know that this weight is 100 newtons in the downward direction. You also know this rope pulling up, because there's one connection here, one rope in equivalency with this one weight. That rope has to be pulling upward at 100 newtons as well. Okay, well, let's look down here. What about now? We have a single weight, but now instead of having one single rope attached, we have two ropes attached and fastened in some fashion to our weight. So then these two ropes up here are now holding the full weight of our 100 Newton weight force. And because this rope is continuous, and therefore the tension in the rope is continuous, we know the tension in this rope on each portion must be 50 newtons. So you can effectively decrease the weight that you would be experiencing pulling on the cable over here to lift your weight by 50 newtons. Similarly, if we continue over here, we can see that with three ropes attached, we actually see 33 1/3 newtons tension along all of the ropes, because we know that whatever the weight is down here, there must be equivalency above it. And so a way to think about mechanical advantage with a pulley system is your ideal mechanical advantage is equal to the number of, we'll say, fastened cable positions that you have to your weight. So in this, your mechanical advantage would be 1, or there would not be a mechanical advantage at all, actually, in that scenario. In this situation, you would have 2 fastened locations of your cable, so that would be a mechanical advantage of 2, 3, 4, and so on. So a way that we can consider mechanical advantage is also as by looking at it as load divided by your pulling effort. This is another way to calculate it, but really I would tend to stick with the number of cables fastened to your weight or your load is going to be equal to your mechanical advantage. And this is really just a way of proving that. See, if you have 100 newtons that you're pulling and a 100 newton load, well, that's going to be a 1/1, or mechanical advantage of 1. If you had 2 ropes attached to your load, you would have a load of 100, and the rope, the tension of the rope that you'd be pulling would be 50, so you'd have 100 over 50, or 2. And so it's really just another way of thinking about it. Now we're going to go ahead and work through some examples of a pulley problem using some of our mechanical advantage equations. We are going to look at an example of mechanical advantage in pulleys. A mechanic lifts a 1500 Newton engine out of a car using a pulley system. The pulley system attaches the cable to the engine assembly at 10 positions. What is the mechanical advantage of the system? What force would the mechanic need to apply to the engine to lift it out of the car? Well, as we discussed on the previous slides, we saw that the number of positions that a pulley system is attached to a weight of some kind of a force, whatever it is, some load, the number of attachments that cable runs through is equal to your mechanical advantage, because we know if we have one cable that is taut and is under tension, all of those forces, those 10 connecting positions, must be equal to the weight of our engine, and they must be equal because it is one taut, tense cable. I apologize. And so we then know mechanical advantage of the system is equal to 10. We don't need to do any more work to solve for the mechanical advantage. of this system. But what force would the mechanic need to apply to the engine to lift it out of the car? Well, we know that the mechanical advantage is also equal to the load over the effort. And in this case, we know the load and we know mechanical advantage. So, doing some quick math, we can solve for the effort to be equal to the load divided by the mechanical advantage, which in our case means your effort that the mechanic would need to apply would come out to 150 newtons.